Hi everyone. Now we are going to discuss a problem given in the Codechef Starter 219 contest named as three parts. So the problem statement says that we will be given integer n and our task is to construct a boolean grid of size n cross n such that there are exactly three write down paths. Starting from the cell 1 comma 1 to n comma n, and it is said that the three paths that are possible in that grid should only contain ones. So first let's try to understand what does a write down path mean. Let's say we are at a cell I comma j. Going right means we are incrementing the jth index by 1. Going down means we are incrementing the ith index by 1. So if we fill the grid entirely with only ones, we can surely say that there are the paths that are possible to start from the first cell and reach the last cell will be definitely greater than 3. So the core idea is to restrict the movement carefully so that there exists only 3 valid paths. Okay, let's now discuss a sample test case given in the problem. The NS3 and the solution that they provided us with was the first row contains all ones, the last column contains all ones. So in this grid, the three possible solutions are going right and going down, and the second solution would be going here, going down, going right and going down, and the third solution is go fully down and go right. So the three paths are like this and like this and like this. Is it clear? We can definitely say that there are no more extra paths that are possible from the first cell to the last cell. So this is a valid answer for the problem. Let's try to understand how to generate this grid for a number which is greater. Let's take n as 4. So we should create a grid of size 4 cross 4. Okay. To understand this solution, let's first fill all the cells in the first row with ones. One here, one here and one here, and all the cells in the last column with ones. Okay, we just now found a single path. I mean, all the remaining cells can be considered as 0 for now. Let's first focus on the cells which are highlighted as 1. Okay, so one possible answer that we found was going right and going down. Okay, if you can observe, we can use this path by making small modifications and create a different path. Let's see how. Let's say if I place a 1 here, so the previous path was like this, something like this. So the new path that we created was going like this and stopping here, going down once and going right and going down again. So we just found another path. Okay, as we require only exactly 3 paths, all we need to do is add another one here, so that the 3 paths that are possible are this and like this and like this. We just found 3 paths. Is that clear? So as we only require exactly 3 paths, we can stop marking ones in this grid and mark all remaining cells with 0. A grid of size 4 can have an answer like this. we definitely have different arrangements of this grid to create exactly three parts, and this is one of the solution, and I feel it is easy for students or anyone to intuitively get an solution for this. Okay. Okay, now I'll give you another example to prove that there are more possible arrangements to create exactly three parts. For I'll take the n value as exactly 4 as previously, n is equal to 4. So we need to generate a grid of size 4 cross 4. Okay, what I'll do is place ones in the first row and ones in the last column. This will become our first path. So the second path can be going down first and going right. So now we created two paths, and the other path that we can use is, as previously said, we can place a 1 here. So if you can see in this path, there are only three paths which start from the first cell and will reach here, that are going like this. Okay, going like this. Okay, and the last option is going down first and going right, and the grid will look something like this. Oh, I'm sorry, I think I have put an extra one here, but that shouldn't happen. Now we can say that we know how to generate a grid for us for any size n, but is that always the case? Can we create a grid in which there exists always three paths? Let's see a base condition where it's impossible to create. Let's say n is equal to 2. So the grid should contain of size 2 cross 2. Okay, and let's try to build the first path, that is going right first and going down. This is the first path, and the other path that can be possible is going down first and going right. So the two paths that we found are, going like this and going like this. Is there any other possible path that we can traverse to create more to create a path starting from this node, this cell to this cell? There are no other paths. So the only possible, the maximum possible path starting from the cell 1 comma 1 to cell n comma n is only 2. So we cannot create any path other than these two. So the answer for this is -1. In the same way, any value of n, that is n is equal to 1 and 2, the answer is impossible. This is the base condition, and for any number which is greater than or equal to 3, we have different solutions or different patterns that we can use to generate the answers. I hope this solution is understood by you. Thank you.